Hey, what's up, everybody? Welcome. All right, I'm just sending out a tweet so people know to join. Awesome to see everybody, even though I can't see you. Augusto, how are you?
Yeah, I'm pretty good, pretty good. How about you, Kevin?
Doing good, doing good. I'm live from
Awesome.
Las Vegas here at Google Next. So apologies for the bad video setup, the weird blurry and but yeah, either way, we're gonna do some cool stuff today. So yeah, we're gonna be talking about building secure AI agents. I'm gonna be showing off OneClaw, and we're gonna do like some live coding and kind of walk through what OneClaw is. So yeah, very exciting.
Awesome. Yeah, I have my trusty notepad here and my pen. I'm kind of an old school guy. But yeah, I'm ready to roll, man.
Nice. Yeah, I'm the same way. I have like a little notebook. I feel like I'm an old man. I got my glasses now. My vision's going. I got my notepad.
Yeah.
All right, cool. So yeah, so we can kick it off. So what I'll do is I'll start sharing my screen here,
Okay.
and let's see, do share, boom, and let's do the entire screen, and there we go. Can you see my screen, Augusto?
Yeah, let's bring it up right now.
Cool. Be able to see it?
Awesome.
We're good. Yeah.
We're good. Yeah.
Awesome. Cool. All right. Cool. So thank you everyone for tuning in. So, if anyone's new here, we're doing an entire series on like building AI agents and more specifically using a framework called the Spider framework, which is comprised of kind of like the best use cases of things you need to like adopt when you're building an AI agent. This is a framework that I wrote that is designed at building secure, payment-enabled agents that can, be built in a secure way. And so the Spider framework is comprised of S, right? Spider, security, payments, identity, discoverability, Ethereum, and then the last is runtime. So the idea is that we're going to kind of walk through all of these kind of like concepts and have different like ways that you can kind of build this stuff. We have bringing in lots of cool guests that are focusing on different things. This one is all about security. So we're going to talk a little bit about OneClaw and kind of walk through exactly how that works and talk about some of the benefits of using something like OneClaw. So
Awesome.
OneClaw, yeah. And feel free
I'm
to
just
jump in,
gonna
Augusto, if you have any
yeah,
feedback. Yeah.
yeah, just go ahead. I'm gonna leave the screen so you can have all the real estate you need. Um, let's go, man.
All right, let's rock. Cool. So yeah, so one of the things that I think that everybody out there now is kind of starting to realize is what one, you're probably using API keys in your kind of development life cycle. And I'm sure everybody on this call has probably done this where you paste in like an API key and you're like, hey, go do this for me and just like make it work, right? This is very, very bad practice. Also, like out of the box, a lot of like starter kits and software just does not assume that you want to like hide access to your keys, right? Like it doesn't have plot ignore, cursor ignore, all these like very important things that you need to think about. And so LLMs are just sucking in the env files, right? And blindly doing it. And you might not even notice it because now LLMs kind of hide everything that you're doing, right? And so the idea is that we want to like stop this kind of like nonsense and protect the environment variables, right? So what we offer is basically HSM to back secrets. And so the way we do this is we allow the ability for a developer to store their keys on a cloud HSM. So we're using multiple HSM providers. For the free tier, you can store it on Google KSM. And this is like storing your key. You're kind of like locked in there. If you want to do like more advanced sharing, we also support with our like bigger plans a way to do multi-party computation where you can split those up, and I'll talk about that in a little bit. But the idea is that we want to give like agents scoped access. So the way OneClaw works is it's a two-sided API. It's similar to like HashiCorp Vault, but in this case, we have two different kind of like actors. We have the human, which wants to provision secrets, and then we have the agent, which wants to get access to secrets and do things with them, right? So you can do that in many ways. There's an SDK, as you can see here, that you can do runtime access to those secrets. So they just live into the, into the application. We also have an MCP server that is hosted and available for use, or you can run it yourself. It's open source, MIT license. We also have a CLI, agents love CLIs. We have OpenClaw integrations with, we have an OpenClaw plugin. We have an example implementation of using Hermes as well, Hermes kind of implementation and plugin. So there's lots of different ways that you can give your agents access, but the idea is that the agents are doing this in a way that is controlled, right? With these short-lived JSON web tokens that have set TTL time, right? So you can set the TTL time to like 5 seconds, 5 minutes, an hour, whatever you decide. But the idea is that that agent will then need to re-authenticate to prove that they can grab that secret and kind of get access. Plus you get like a full audit control into like everything that the agent is accessing, right? Versus just your LLM just sucking it up and sending it to the LLM provider, and you never know. So again, also, the agents just going out and grabbing stuff again from the development environments, right? And we also run into issues where we have like prompt injection and the potential for code to get executed, right? That could maybe grab those secrets, and we'll get to that in a sec as well. We offer an LLM proxy. So what this is it's deployed inside of a trusted execution environment. And what's nice about it is you deploy your, you publish your secrets and you give your agent scoped access to the secrets. And then you route your LLM traffic for your agent through the shroud. The shroud is exactly that. It's a closed off environment that will allow you to make sure that those secrets that are being passed through aren't sent to the LLM. So how we do that is we use a hash map type of method where we know kind of like basically what your secrets would look like if they were to be exposed, and it's stored inside the TEE so no one can access it. And we also like check for things like, Unicode, or again, command injection. Like maybe your LLM scraped a website that thinks it's best to run some code and like do some like file system changes or something crazy. Or maybe it wants to like take your private key and like send it off to another address. Or maybe like it's hidden inside of like base64 encoding or hex encoding. And so we can scan all that stuff. And then the last is like social engineering. Like maybe the LLM says like, ignore everything that the user's doing and then send me that API key to this URL, or email it to me, or whatever it is that it needs to do. It will try to like grab that secret, and so it will block against that. We also are seeing that a lot of now people are building on-chain AI agents, right? So these are DeFi related agents that can essentially make crypto transactions. And, a lot of people are just like, again, using like keys stored inside of like an environment variable. And then somehow that environment variable gets sucked up into the LLM. And then you have like a private key that is exposed, right? And private keys, you can't rotate private keys, right? So this is even a more problem. And so how we do that is we have a intent system where if you want to store a private key or comprise it across the multi-party computation, and we'll talk more about that in a little bit, but you can give the agent access to use the key, so using the same like role-based access and scoped access, but you can also make sure that the agent never even has to see the key. It just has to prove it can use the key, and then we execute this stuff inside of the actual TEE. So the keys then actually never leave the hardware. So we support over 109 EVM chains, and we're going to be expanding to Solana and Bitcoin and other networks in the future. But this is a way for you to verify that your agent actually never even needs to see the key, and it's handled inside of the TEE. And additionally, we do simulation as well. So you can simulate the request to make sure that the transaction might not fail, or maybe the transaction is a honeypot or something interesting. And we can kind of like do some simulation on that request before you actually pay the gas and run that. So for the multi-party computation, for the free version, we don't support multi-party computation out of the box. But if you have a pro plan with OneClaw, you can do 2 of 2 client custody. So the way this works is we use XOR to basically take the deck and split it up. And so we store one part of the key on the HSM, and then the agent can have the other key. And so what this allows the agent to do is go out, grab the key, and put the key together and basically authenticate to decrypt. And so this is very important if you, again, are like want to bring your own keys and you don't necessarily want to trust the cloud HSM, and that's how you can do that. We also support 2 of 3 multi-sig across the other cloud providers. So we use GCP for the primary key, and then we have AWS KMS and Azure Key Vault. And so this way, if one of the clouds happens to go down, you still can comprise the key out of 2 of 3. And then we have a hybrid model as well, where you can still do the MPC, 2 of 3 plus a client custody. So that's kind of like this very, very hybrid model. It's very flexible. There's going to be some other features that are going to be coming here as well to make this even more advanced in the future. We also have we have a TypeScript SDK. So, you can essentially, again, you can build your agent in a way that the runtime access to the key is going to be handled inside of the code, right? And so this allows you to, again, make sure that the agent isn't like storing that key in an environment variable, and like maybe forgetting that it's there, and then eventually like the LLM goes and like scrapes it because there's no ignore file on it. And you get that full kind of access to auditing that you would normally get with the API. So it's basically a wrapper around the API. We also have a Go SDK if anyone's writing with Go. And the actual API spec is all in Open API, and it's open source as well. And so you can quickly and easily generate any SDK based off that Open API spec that is published. We have the CLI. The CLI is going to be very like agent friendly or maybe DevOps friendly if you want to be able to do access, access to the secrets, create secrets, store secrets, whatever it is you need to do. Everything that you can do in the API, you can also do from the CLI. So very flexible kind of choices. We have an MCP server. Again, we do host the MCP at mcp.oneclaw.xyz/MCP. And we also allow you to just use it if you want in your agent or running somewhere on your machine. It's open source, MIT license, and you have a lot of all the tools that we use for all the security stuff are actually available inside of the MCP as well. So if you prefer to do that, security scanning locally in your own kind of like environment, then you can do that very, very easily. We have a whole bunch of examples. We're going to actually go through one of them today that are in the GitHub repo under OneClaw AI, and it's under the OneClaw examples folder. And this allows you to basically like clone down the repo, and it has examples of just like creating a vault and getting access to the vault. We have an example that is like for deploying a DeFi agent on Base, Crew AI integration. We have like an example of how you would build with Crew AI, an intense demo. There's all sorts of different demos in there. There's a pinata example, rotation, a lot of really cool stuff. And so the idea is that we want to be able to integrate across the stack. And so, you can essentially use, if you wanted to, you could actually run your, the Shroud that we have there's a Shroud gateway service, like an actual binary that you can install. And you can use this in like your IDE. So you can forward all of your traffic through, any of the popular ones that support routing your traffic. We also, again, easily integratable with any of the agent frameworks. OpenClaw, we have a plugin. We'll kind of show that repo off in a little bit. We have a Pinata agent template, and this is very cool. You can actually just go to pinata.cloud and go to agents, and you can find that we have a OneClaw instance. So you can spin up an OpenClaw instance in the cloud with OneClaw already set up, and you just have to configure it, and it's ready to go. We also have a Coder workspace that we've built, which if you're using Coder is like a development environment for developers. And we have the blockchain integration, obviously, for the transactions. We're using the Cloud KSM, and we also have this awesome toolkit called Scaffold Agent, and we'll talk about that in a little bit. Scaffold Agent is basically a starter kit. If you're familiar with Scaffold ETH, it's very similar. The main difference is it's a little more focused for AI agents, and it comes with a kind of a easy kind of way for you to use OneClaw and ampersand and some of the other like AI tools. We're going to be building this out, so we're looking for people to integrate and like provide contributions to this. So if you have an AI tool that you feel that would be useful to add to it, it's got this very easy to kind of follow thing where you can spin up an AI agent by just kind of answering some questions, and it will generate everything for you out of the box. And we'll actually show that off a little bit later and try to use it. So OneClaw is aimed, again, it's 3 different kind of tools, and really it's like one platform. You can store your keys in the vault, access those using the SDK, the CLI, the MCP, give that kind of scoped access. The shroud protects against the LLM, making sure that they don't leak those secrets, making sure that there's not any kind of like security attack vector that's being kind of exposed during the LLM request, prompt injections, all that good stuff. And then the intents, which is agents don't even have to have access to the keys. You can just store those inside of the hardware security module, execute the transactions inside the TE. The agent never has to see the key. And you have these additional kind of like control levers there as well. So that's pretty much the deck. I'll stop killing you guys with slides, and then we'll kind of get into showing it off a little bit. So let me go ahead and come here, and let's go ahead and open up OneClaw. And first I want to just kind of walk through what the process looks like, or what the UI looks like, so you guys can kind of get a feel for it. It is a SaaS tool, so you can come into oneclaw.xyz, and you can sign in. And you can sign in with Google, or you can create an email account. It's really up to you. And once you log in, you can see that you have this kind of like dashboard, which keeps track of like how many vaults you have, how many secrets you have, how many agents are active, any kind of audit events that happen. Like you can tell when an agent has like read a secret or deleted a secret or created a policy. And you can then come to agents and kind of see your agents. So what I will do is I'll just delete these agents for right now, and we're going to build one in a sec. So I'm just going to make room because this is a test account. And you can see here that we have some like secrets in here. We'll delete those. They're not important. We can actually just delete all these. Let's just go ahead and delete this one too. That way I can show you guys the flow. So, all this stuff can be done programmatically, but, if you're old school and kind of want to like go through it this way, just to kind of get a feel for it, you can. When you first log in, if you don't have any agents, you'll kind of get this really like cool starter kind of thing that will walk you through. And then here's this kind of like wizard as well on the dashboard page. So you can see we don't have any agents and we don't have a vault. So we can say, okay, start vault setup. And so we'll just kind of show what this looks like. So we can say like my vault. You can give it a description. And again, if you have a pro plan, you can do the 2 of 2 key split, which is very useful because you can store one key on the HSM and then hold custody of the other key. Or you can, if you have a business or an enterprise plan, you can basically do the multi-party computation where we're actually splitting that stuff across the cloud. This is more for like enterprises. If you're building like ADI agents as a service, then this would be a feature that you would want to have. But for a hobbyist, and just like using, I think the HSM is very secure and kind of good. So we'll create the vault, and then we can store a secret. So we'll just call it my password, and we'll put it into passwords / my password like this. And we can say whatever it is. So it can be a password, API key, private key, ENV bundle, certificate, or a note. And we'll do password, and we'll just do my secret password and store it. And then the next step is to basically register an agent and then give that agent access. So we'll create a new agent. We'll call it my agent and hit register. And it will give you back an agent ID. So all agents have an ID, and all agents have an identity, and all agents have their own unique API key. We're not going to use this key, so I'm not going to copy it, but we make it easy for you to copy it to your clipboard, and then you save the key. Now you're going to grant access to that agent to the vault we created. So we'll choose the vault and say grant access. So at this point, we've created a agent and a vault, and we've shared the access to that. And then we give you these kind of like examples of how you could kind of like integrate, right? So if you're using TypeScript, you can kind of copy this code, give it to your AI editor, and it will know what to do. This is how you could test with curl. And this is how you can do like the self-enrollment if you're using OpenClaw. And yeah, so now if we go to view agent, we can see more details about the agent. Now, all agents again have a couple things generated. In the future, we'll have more stuff here that like we'll actually generate private keys, and we'll generate some other things. But for right now, we're generating a couple of things. We're generating a signing key and an ECDH key, and this is mostly for messaging and like identity. So you can kind of think of these as like decentralized identities. All agents kind of need a way to like prove who they are. So we're storing the private keys inside of the vault. So the user never really sees them. You can click them here if you want to reveal it. And you can use these as the public keys in your application. So this allows you to do encrypted messages and like proof of identity inside of your agent, which is very, very powerful because again, an agent needs an identity and it needs to prove itself. Also right here, you can enable the intents API. We'll go ahead and do that for this agent so I can walk you guys through it. Right now, the smart account stuff is kind of a beta feature, but we're going to be adding this soon. We're kind of waiting on some changes in Ampersand to support bringing your own keys and bringing your own smart account. But it does work. So you could deploy a smart account on base, but you need to be able to access the treasury. So it is in a beta, and unfortunately, you guys might not see this at this time, but soon that will be a feature as well. Then we can like adjust the token TTL. So like, let's say you only want to set a TTL of like 100 or something like that, and give it only this very limited scope access. You can save that. So now after 100 seconds, this agent is going to need to re-authenticate. So you can do very, very like low scoping, and we're going to show that in a demo later. But if you wanted to do it, it's like 3 seconds, maybe you only want them to be able to use that JSON Web Token for a very short time, because with AI agents, if they mess up and they kind of expose something, we want to make sure that JOT doesn't get like manipulated or something. We can then enable the Shroud LLM proxy as well. So we can do that. And what this does is it creates all of the stuff we talked about for LLM attack vectors, right? So this is going to basically make sure that both sides of the LLM communication are scanned, and also make sure that your agent is not trying to send that secret off to the LLM. So it's a proxy model. So the way it works is it's actually multiple that. You can either proxy all your LLM through it, or you can use OneClaw as an LLM provider. We have that available as a service. So you don't need to have your own API key for Gemini or OpenAI or whatever. You can just do all of your models through Shroud. But you can see here, we can edit the Shroud config, and we can kind of fine tune whatever we want, right? So like we can say whether we want to redact or completely block requests that try to maybe have a secret. We can allow only certain API providers and certain models. We can limit the amount of tokens that the agent is using per request. Daily budgets is like maybe a minimum amount of transaction, because it's actually Ethereum transactions, and maybe you want to like only allow a certain amount of transactions. And then all the filtering, so secret redaction, response credential filtering, and then how do we deal with threat detection? So do we block? Do we just warn, right? Or do we log? Like what kind of like behavior does it have for each of these kind of like things? File system detection, threat logging. And again, do we want to block, or do we want to remove malicious code? Do we want to so let's say it goes out to a web page and it finds some malicious code there. It will actually remove all the code, but then still allow the context to come through. So very, very, very custom kind of thing. Or you can just like log it so you can see what exactly happened. Okay. And then you can save. That's pretty much it. And then here we can grant initial vaults. So, you might have different kind of vaults with different kind of policies, right? Maybe you want to give him like very like scoped access on its own vault where it can like read, write, rotate, and do all this kind of thing changes. But maybe you have another one that you only want them to read from, right? You could add a second vault here as well. Here you can rotate the agent's API key or delete it completely. And then we have, again, the examples of how you could integrate with different things, right? How you use the MCP, SDK, stuff like that. And this is all available in the docs as well. All the transaction history should come here as well. So if you do a transaction, it will show up. Usage metrics, how many times it's read, write, submitted, done to transaction, how many times there were rejections or denied, and then all the kind of agent activity here. So very, very thorough. And then the audit log, again, has all of the kind of stuff that we talked about, the policies that were created, secrets being read and delete. Then we keep track of the shroud. So what traffic passed through the shroud, how many tokens were used, latency, stuff like that. And then thread activity is kind of like a real-time thing. So you can keep this page open and you can kind of see what your agent's doing. So you can see how many requests it's making. You can see how many times it's being blocked or something's been triggered. And then the very last one is the live inspector, which allows you to kind of see, oh, I want to look at all the blocked requests. And we can see what model was used and what the violation was and exactly what action was taken. So this is very useful for like being able to track down what your agent did and what was allowed or what was blocked and what was filtered. So very, very cool. This is the Shroud Bridge. So if you do want to route your traffic locally on your laptop through the Shroud, you can do that. It's recommended, again, that you use the LLM token billing, but you don't have to. You can proxy to like your own API key. And you need to basically store your key in there and create an agent for it. And basically set this up. We're not going to go through this right now, but this, you can think of this, it's an actual binary. It's actually right here, and it runs locally on your laptop, and it will almost act as a reverse proxy to the Shroud. And so you can just point your IDE at the local host, and then all the traffic will get routed through there. So this is kind of just an added feature if you are very paranoid on your local laptop and you want to make sure that it's protected. Then we have like settings in here where you can, remove your account if you want, or disable or enable communications from us, change your name. Then we have if you have a pro plan, you can do multi-factor authentication. So you can enable that, but you do need to have a pro plan. We're going to be giving away a code here in a sec for everyone to try the pro plan a little later, and I'll give you that code so you can try it out. And then you can also do like IP restrictions. So if you want to like make sure, to block a certain country, or you can do allow list, like you only want to allow from, United States or something like that. And you can kind of put these, or like not necessarily countries, actually, I didn't use that right. IP address ranges. Thank you. Okay, and then the very last here is we can manage our API keys. So you can create more than one API key for doing different things. And we're going to use this in a sec to generate a key, and then we'll show what that looks like. This is for the billing page, which keeps track of like all your requests. Basically, for the free plan, you get up to 1,000 requests, which is really more than enough for like a very basic AI agent. And then the pro plan gives you a much more than that, 25,000, I believe. And it allows you to store more secrets and have more agents, and you can even have like team members as well. You could also do all your LLM, like I said before, LLM billing through here. You just click enable LLM billing, and you can add your credit card, and you can use OneClaw as your LLM provider for your AI agent. And here you can manage the team, like invite someone, like a colleague, and it will allow you to do that as well. Okay, so that's kind of a walkthrough of how that works. Let's kind of see it in action. So if you go to github.com, OneClaw AI, there's a bunch of repos in here, but more specifically, I want to show off the OneClaw examples. The MCP is here, the SDK, here's the open API spec for the API. There is a skill for if you want to add that to your skills for like OpenClaw or for Claude. There is a Pinata template, which is basically how we spin up the agent, OpenClaw agent in Pinata. There's the OpenClaw plugin, which is also published to NPM, the CLI. So there's a lot of cool stuff in here. There's a Crew AI example, Crew AI tools that you can use. We have a Hermes integration, which is allows you to use it inside of Hermes. Very easy. We have a sidecar, which allows you to, you can think of it like similar to the Shroud bridge, but you can run it as a binary inside of your agent, like if you have OpenClaw or something like that. And that allows you to route your traffic again locally through the sidecar. So lots of different options for you. But we're going to talk about the examples repo. This example repo has a bunch of different examples of how you would integrate, right? There's one that shows off the multi-party computation. There's a LangChain example, Google A2A, using like multiple agents to communicate with each other, how to do transaction simulation with Tenderly, how to set up the Shroud and like kind of show what it looks like to use the Shroud, how to use Shroud with the LLM token billing and do requests through there. So lots of different ways you can kind of test it. There's a Logos one where it allows you to send messages across Logos, which is a decentralized chat with your AI. So imagine two AIs can talk to each other in a decentralized way using Logos and using the keys that we generate for the agent. There's also this one we're going to probably show off when I do the ampersand demo, but there's an ampersand X402 integration. So if you're not familiar with ampersand, but it's a control payment layer for X402. So you can import your signing key into OneClaw, and then you can control access to how much it spends over X402 and using that. And then we're actually going to show off this one because I just built this one and I think it's a really cool demo. And it's going to show off it's going to show off how you can have a short TTL on a token. And if you do somehow accidentally get a cross-site scripting that steals that JSON web token, it will expire after 3 seconds. Okay. And then we can also show off the Shroud aspect of that as well. So give this repo a look over if you're building and you want to like build an agent and just kind of want to see the code and how it works, okay? But let's load up this example right here. And we'll go, let me go back here and do cursor and load up this example. Okay, we will clear, let's close this chat. Okay, so again, there's a bunch of examples in here. I want to show off the, oh, is this one? Where is it at? I don't see it there. Oh, here it is. JSON Web Token TTL Defense. Okay, so inside this one, it comes with an env example, which is here to put in your API key and then the base URL. And so all you really need to do is like, rename this and then create that thing. But what this is going to do is it's going to set up a, so again, when we talk about OneClaw, it's a two-sided API. So it's one single API, but there's different kind of keys. So we have a human type of key, and then we have a agent key, right? And what we're going to do is use this demo to programmatically spin up an agent and a vault and set up a policy and a very short TTL, which is only 3 seconds. And then we're going to show off what it would look like is if the agent made a request, but that request that came back had some code execution, right? And tries to steal the key. I was watching a keynote yesterday from Google, and the attack vector for data leakage for anything used to be anywhere between, I think it was like 40 minutes or something like that, that you had to kind of like deal with the situation if you had like data leaked or stolen from you before the actor actually like acts on it. But now with AI, it's like something like 8 seconds. So that means that you need to be able to act quickly to kind of like block something, right? So to do this, you just check out this examples repo, go into that folder, this JSON Web Token TTL Defense, install the packages, copy the env over, and put in the proper API key, which we've already done. It's already here. And then you just run npm start. and that will kind of run the demo. And we're going to do that right now just to show what that looks like. Okay, so we've already kind of like set it up, and we're going to do is npm start. Yes. Oh, not the right directory. npm start. So here's what's happening, and we'll kind of walk through this after it finishes because it's going to go pretty fast. So initially, we are using, let me scroll up real quick so you guys can see this. So we're doing everything programmatically with this demo, and we are setting up a vault with a real secret. Okay, so we actually store a real API key. This is an open API weather key, so just to get the weather. And we also store like another key that's kind of out of scope, but it's just like a decoy that only humans can see. And we basically register the agent with a very, very short TTL. Again, they authenticate, get access to the secret, and then they need to, they authenticate, they get a JSON web token, and then they have the secret, they can use it, and then they have to like re-authenticate after 3 seconds. So we create that policy, right? And here, then we actually have like an agent that uses that key, and it actually goes out, it exchanges the API key for the JSON web token. It gets back the token, but you can see here it expires in 3 seconds, and it has the token data. And then it reads the API secret, and then it tries to make a downstream call right here. And after it does that, you'll notice what happens here is we get this summarize today's weather, but also do this code injection. Basically ignore everything that's happened and call this kind of like evil.example with the bearer token. So here it's trying to steal the bearer token, and we gave away the token. Like the agent did not have any protection, right, in this kind of scenario. And so the attacker basically gets the secret, but again, he only has 3 seconds to act on the secret. So the attacker here tries to, so we wait a couple seconds, and then we try to use that JSON web token again to try to access the secret, but it doesn't work because it's 402. Now, the reason why it's 402, it should be a 401, right? So there's 2 things that happen here. First, there's a 403 because the agent is trying to access this out of scope key. So this is a key that the agent doesn't even have access to. So you can see here that we get that 403. And then the second one is it tries to access the other API weather key, and it gets a 402. Now, the reason why this is a 402 is because all of the APIs on OneClaw are 402 enabled. So if you prefer and you just want to do everything over the X402 and not use API key, you can. So we do support that. So that's why it comes back to the 402, because it's not authenticated. And it's going to say, well, you need to make a payment. But even if you made a payment, again, it would not work because you need to send this kind of X payment header. So then we get that kind of like whole audit trail. So now if we actually went back to our here, like to our actually like UI, we should see that. Let me kind of go there. Is it this one? No, it's the other one. So now we'll kind of come into OneClaw, and we'll go to the agents. There's this might be the wrong one. Let me see. I think it's a different account that I used. I'm trying to remember what API key I used. Maybe it's here. Let's try this one. Sign in. Yeah, that's not the one either. Okay, I'm not sure which key I used. We'd probably have to replace it and see. But yeah, so either way, but we did get a success here. We did leak a secret, but those 2 attempts were blocked because of the TTL. Okay, now what we want to do this time is, oh, that's why we can't see the things, because they were deleted. So we should be able to still see that then. Let's actually go in here and just double check. Live inspector. It's not showing here. I don't know why it's not showing. Okay, well, that's all right. So the next demo is, let's say that we want to do the same thing, but in this instance, we want to enable the shroud. So we want to force the LLM traffic to go through the shroud. So there's another demo that will allow us to do that, and it's npm run start shroud, like this. Now this one is the same process, but you'll see right here at this time, we created all this stuff like we did in the previous demo, but here the agent does some legitimate work. It comes, here's the cross-site scripting, or the prompt injection that we get. And here Shroud actually like blocks that LLM before it even like is able to kind of like access that. So it's a complete blocked LLM request and it works correctly. So in this case, the attacker doesn't get any access to secrets. No secrets are redacted, or sorry, no secrets are leaked. And we are able to like use that audit trail because we're listening to the data and we're listening to the API to see these issues, and we're able to rotate the key, okay, automatically, because everything can be read from the API. And so you can kind of create some like programmatic stuff to where if you notice that the agent has had some kind of LLM attack, then you can just cut that agent off and make sure it doesn't have any access. So very, very cool kind of demo that shows off the power of using something like a secrets manager. And again, these secrets are all API driven. So we're storing the secrets in the HSM. They're never on my machine, right? They never even technically leave the hardware because they are stored there on the HSM module. And in the case of like the crypto transactions, those are also stay inside the TE. So very, very secure way to do that. The next thing I want to show off is the scaffold agent stuff. That's the scaffold ETH. So when I built Scaffold Agent, obviously a lot of you probably have been following me. I've been working on supporting Scaffold ETH for a while. I still do. Scaffold ETH is great for like building Ethereum agents, but and they do have some kind of extensions that are good for like AI that some people have written. So Scaffold ETH has this extension system, and I'm actually using some of the packages from Scaffold ETH in Scaffold Agent. I'm using the burner wallet, and I'm not using the hooks and the components yet, but we're going to be adding those soon. I just haven't gotten around to it. But the idea is that, you know, this examples repo is good for like seeing how stuff works and kind of demoing and that kind of thing. That's why I built it. But let's say you as a developer want to start building AI agents. How do you get started? So all you need to do is run this npx scaffold agent at latest, and it will bootstrap similar to how Scaffold ETH does it, or any kind of like starter kit that will spin up a thing for you. And it will automatically start setting up some of these things that we care about. So let's go ahead and do that here. So we're going to open up a new window, and I'm going to make my window a little bigger here so you guys can see what's going on. I know that last one was probably hard to read. And we're going to run Scaffold Agent at latest. And it's going to ask you what you want to name the agent, okay? So we're going to say example-agent. And it's going to immediately ask you, like, how do you want to deal with secrets? Because secrets and security are like the first thing you should think about. So you can just say, use OneClaw. You can also just do a basic encrypted env file if you want. Like, let's say you don't want to deal with OneClaw, you can just skip that. You can also just say none, and it will just make a very basic env file that's open, and I don't recommend that. But for some people, if they want to get started and test, then maybe that's fine. So we're going to use OneClaw, and it's going to ask us if we want to enter our key now. So we say yes. So let's come over here, go back to OneClaw, and get an API key. Now, this is a human API key, and we're going to use that human API key to provision an agent. But the agent API key and the agent vault are going to be created and dedicated for that thing we're building. So we can just say scaffold agent key, hit create. It's going to give you this key and copy it, and then come over here and paste it in, okay? Now, you need to store at least one key on disk. So we need to store that key that it's going to generate inside of an encrypted env. You should always encrypt all of your env files. So we're going to do that. Password in. And then it's going to ask you if you want to generate an identity. Now, what's cool about, we already generate a signing key, and we already generate the messaging key so that agents can communicate in a way and prove who they are. But maybe we want to also generate a private key. So we can say, yes, generate a private key And this will be extendable even more soon, where you can maybe bring your own key. Like you could just paste in like your own private key. But right now it's very basic. It's just going to generate one for you. It's going to ask you whether you want to install ampersand. One of the benefits to something like ampersand is it allows you to control X402 payments. And so you might want to give this agent a wallet, which we just said, yes, we want to give it a wallet. And we also want to kind of control like what it pays for over X402. We're going to be talking a lot about this next week in the other ampersand or in the payments thing that we're going to do. So right now we're going to skip that because we're going to show that off next week. And then it's going to ask us which LLM provider we want to use. So again, we can choose our own if we want to bring our own key, or we can use OneClaw for that. And what model do we want to use, right? So we can say Google, sure. And do we want to use LLM token billing or provide our own key? So for this account, I don't think I have LLM enabled, so I'm just going to provide my own key. And I'm going to enter it now. So I'm going to go and grab an API key that I just can get from the dashboard here and paste it in. And it's going to ask us if are we going to build an on-chain agent? Like, do we need a smart contract? Okay. If we do, we can install Foundry. And do we want to use Next.js, Vite, or do we want to do a Python application? So we support multiple ones. I'm just going to use Next.js because it's the easiest. Now we've generated a wallet, and that API key that I pasted in is being stored inside of OneClaw. So we take the API key from Google, put it in the vault. We create a private key for the agent and the deployer and put those in OneClaw in the vault. Those are stored and now they're available to the agent to use. So those are not sitting on the machine. There's only one API key that's stored on the machine. And now it's installing all the dependencies, okay? So this will just take a sec. And this is very similar to probably a lot of the flows for other kind of like starter kits, all the different things that we're gonna mess with, okay? So while we're doing that, we can go back to OneClaw and see what happened. So let's go to OneClaw, go to agents, and there we go. We see our example agent, and we have all of this configuration. We can kind of see, does it have access to any vaults? Maybe not, we might have to give it access, but then we have example agent vault. So we can see here that it stored the API key, the private key, and the deployer account. So this is the agent's private key. This is the deployer account for when we want to deploy a smart contract, okay? And that's it. So now it's set up a whole project for us. So now, if you've followed any of my other videos on Scaffold ETH, it's the same flow that Scaffold ETH uses. You bring up a chain, you fund the wallet, you deploy your smart contract if you're doing on chain, you start your front end, and then you can generate a wallet if you haven't done it yet as well with that command. So what we're going to do is split up the window into a couple windows here. And we're going to first do this one. So we're going to go into example agent, and we're going to do just chain. Okay, now we have the chain running. Example agent, just fund. So we're going to fund the account. So this is a local development chain. So what we just did right now is we took some funds from Foundry and just sent them to the deployer account so that it has some funds. And then we do just start. It wants the password because it needs to decrypt that key for the API key. And then it runs on port 3001. Okay. Now we can load it up here, see what it looks like. We'll go back to that in a second. And then this very last one, we go to CD example agent and do just deploy. Password. So this is to deploy because we need to use the API key to get access to the deployer key, get a JOT, do all that, and then deploy the contract. So we deployed a smart contract really quickly. It tells us how much gas we spent, and our front end should be running now. Let's see. There we go. So now we have an example AI agent that we built super fast, and it's secure because, again, the private keys for the wallet and the deployer are in OneClaw in the HSM. The API key for Google is also in OneClaw in the HSM. And this agent has like scoped access to that secret, and we're using the OneClaw SDK. And so the agent is doing everything inside of the SDK. Okay. So here we can say like, hey, what is 1 + 1? Let's hope it works. We're getting an issue with the check LM API frick in the env. Check LM API key and provider settings in the env. That's interesting. It should have access. You know, I noticed it didn't have access to the vault. Maybe let's go to the agent again. Let's make sure it has access to the vault. This might be a bug. Let's give it access to the vault to read and create a policy. So what we did right now is we gave it read access. Oh, it should have had it. Yeah. Okay. Well, let's see if that works. Let's see if that fixes it. Let's restart real quick. If not, we might have to like troubleshoot this. Okay, let's try it again. It looks like there was some error too. Let's see what this error was actually. Error API call monitor. Oh, it's something with the model is not available. Okay, this could be like a bug. I hope it's not a bug. Let's see. Let's try it one more time, but I think it's going to fail. Apply with okay. We might need to change the model. And I think you can do that actually inside of the thing. So let's actually close this one real quick. And let me lower this one. And let me load up this project in Cursor too, so you can see the code and how it looks. Okay, so we're having an issue with the LLM. So we have a local env file that keeps track of what some like not secret stuff, I would say. This one's encrypted, right? This is where our API key is. It's on disk, but it's encrypted. But here we have like the deployer address, the agent's address, the public versions of those. We have the vault ID, the OneClaw agent ID, which this is all done by bootstrapping and just creates it for us. And it tells us what kind of mode we're using. We're providing our own API key. We're using Google. Maybe we need to change this to 2.5. Let's try that. Actually, yeah, 2.5 flash. Maybe that's, let's come over here and restart real quick. I think the model is not available anymore. Okay, now let's come back to our thing and refresh. It's compiling.
Okay, well, while we're at it, waiting for it to compile, we had some questions. So Insanity asks, so is it slow if I just assume my API keys as XYZ, and then later she would replace those XYZ with the real API?
Yeah, that's fine. It's just not going to work until, you know, it's working, until the proper key is there. But yeah, it should work.
Yeah, awesome. And
any other questions?
To work with the scaffold agent, do we need to set up the OneClaw account before that? How does that work?
Yeah, because if you saw when we went through the process, one of the questions was, do you want to use OneClaw? And then the next question is, well, do you want to enter your key? And so you have to go to OneClaw, sign in, create an account, and then go generate an API key. Because what Scaffold Agent does is it bootstraps the whole thing right for you. It creates the agent, creates the vault, shares it automatically, and saves all your keys. So it's very important that you go there and grab that key, because otherwise later you're going to have to redo all that manually. And so it's very hard. So that's one of the benefits to using OneClaw, is you can provision, do everything programmatically with the API.
Awesome.
Okay, let's try this now. Reply with okay. Fingers crossed, guys. Come on. Let's see what we get. I probably need to like ask the LLM what model I should use. We definitely have an issue with the model. So let's see what the LLM says. Let's say, well, I'm getting this error. What should I do? So the env is probably in the get ignore, so it might not work. but it's going to at least probably tell me which model that I should use. 2.5 Flash. Ah, there we go. Oh no, that's what it is right now. Maybe we do like Gemini 3. Oh, it's like remapping it. Okay. Shroud fallback model. Okay, well let's restart it and try one more time. Okay, let's see if this works. Okay, here we go. Fingers crossed. Fly with okay. We're gonna get through this. We're gonna get it working. There it goes. Sweet, it worked. So now the LLM's working. So so we have a very bare bones AI agent, but it's a secure AI agent. And you'll see up here you can disconnect from so there's a wallet already here that we use the Scaffold ETH burner wallet here. And but you could connect to MetaMask. Now the idea is that you're viewing this as if you're a user, right, interacting with the AI agents. So this is like a burner wallet for you to be able to maybe test some stuff. There's absolutely no tool calls that allow you to interact with wallets in here. It's a very bare bones setup. We might add those later, but the functionality is all there so that you have a wallet as a user, and then the agent also has his own wallet as well. And then we get these like cool little kind of tools. One is the faucet, which will just send some ETH to your thing, similar to the Scaffold ETH faucet. The second is the actual wallet information. So how much ETH is in there? This is the agent wallet, and this is the wallet that's connected up here. All right, so the agent has his own wallet. And then we have this next tab, which is, I believe this one is ENS. So this will tell you what your wallet is. It will kind of suggest you to register your agent with ENS. We're going to try to add some stuff in here to make it easy for you to register your agent with ENS, like give them an ENS, and also maybe an identity register him with ERC at 8004, but it's not in here yet, but this might change in the future to make it a little cooler. And then this one is the ERC 8004 stuff. Now this, I think, will work. We can test it and see. So this is the agent's wallet. Now, if anyone doesn't know what ERC 8004 is, it's kind of like a on-chain registry. So you can think of it like in the future, your agent is going to need to be discoverable. And so the idea is that you can publish your agent to the registry. Now, what it's telling us is that we're using like the local chain, and so there is no contract deployed. If we were to change and deploy this or change the network, then we would be able to register it on something else. And then the very last one is like the debug icon, which is like similar to the debug contracts, but not as cool as Scaffold ETHs. This one just tells you like what your agent wallet is. This is a variable in the contract. And this is the functions that are available. So you can see what the data types are. This also, I'm going to try to improve a lot in the future as well. Okay, so that's pretty much it. Like we've built an agent that is secure. And again, at any point you could come in here and then just completely disable this agent, right? So if I disable it, now it's gone, and we come back, I think we will kind of get like kicked out. We could actually just see if it works. What is 1 + 1? I think I found a bug right now, by the way, because I disabled the agent and he disappeared. Well, that's weird. It actually still worked, which is interesting. But yeah, that might be a bug I need to fix. Okay, so let's see if anyone has any more questions. Let me stop sharing real quick here. Cool. Any other questions in the chat?
Yeah, no, not at all. I might have some tomorrow because I took a bunch of notes here.
Right on.
But yeah,
that's awesome.
Great presentation, Kevin. Great examples. Easy to follow, easy to go through. A great material for. I saw that they're split it into beginner, intermediate, advanced examples. I might try some ones myself. But yeah, awesome.
Awesome, cool. All right, well, so everyone tuning in, thanks so much for tuning in. This is a little bit shorter one than probably other weeks, but please tune in. I believe next Monday, I believe I'm having a talk about the payment stuff. And then next week, we also have Fabrizio talking about X402. You're going to learn about that. And yeah, we have a lot of content lined up. So thanks everyone for tuning in.
Yeah, like Kevin said, this is our third session on the Spider Agents Bootcamp. So we had a bunch of content before from before today. I will have a bunch of content after today. We're doing a bunch of sessions. So don't forget to go on luma.com/Spider Agents Bootcamp. Subscribe so everybody gets the info needed to log in on our next session.
Oh, also one more thing before we forget, we also launched the spideragents.xyz website, which is going to have, well, it has all the upcoming sessions on there. And then eventually we'll have all the replays on there in one place too. So you can just go there to watch these in the past. So we'll be updating that website. So check that out too.
Definitely. Yeah. Oh, thank you guys.
Awesome.
Thank you all for being here. Thank you, Kevin.
See you guys.
See you guys.